Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4 motion in a plane. Today we are going to continue the dot product or scalar product. Right? So in the previous class we studied product of two vectors, or we can call it as multiplication of two vectors. Multiplication of two vectors can be done in three types, and they are scalar is multiplied with vector, and vector is multiplied with a vector with result scalar. Third one, vector is multiplied with a vector with result vector. So we are going to call them as scalar product and vector product. Scalar product is represented by a dot, so we can call it as dot product. Vector product is represented by the symbol cross, so we can call it as cross product. About cross product or vector product we can study later. So now let us continue properties of dot product. Yes, in the previous class we studied what is a scalar product, how to represent a scalar product, and also we studied the first two properties of a scalar product that you can remember. Yes, what is a scalar product? Scalar product of two vectors is defined as the magnitude of two vectors and cosine of angle between them. And the equation is given by, here I am going to write vector A dot vector B. This is scalar product, and this is equal to mod of vector A into mod of vector B into cos theta. Or simply we can write AB cos theta. This is a scalar product. Yes, how to define a scalar product? Scalar product is the product of magnitude of two vectors and cosine of angle between them. Right? And this scalar product or a dot product, it is represented by dot. So we are going to call it as dot product, and this dot product is commutative. So we already proved the dot product is commutative, as well as the dot product is distributive. Commutative means A dot B equal to B dot A. Distributive property means A dot B plus C is equal to vector A dot B plus vector A dot vector C. So these two properties we already studied in the last class. Let us continue with the third property. Yes, what is the third property here? Dot product of two vectors is maximum when vectors are parallel. So dot product of two vectors, its value is maximum when vectors are parallel. Parallel means the value between A, for example, I am going to consider two vectors. Observe here. This is vector A, right? Then this is vector B. Let us consider two vectors, both are parallel. If both are parallel, then angle between these two vectors is how much? 0 degree. Now according to dot product we know that vector A dot vector B is equal to mod of vector A into mod of vector B into cos theta. Mod of vector A means simply we can write its magnitude A into B into cos theta is how much? Cos theta means theta is 0 degree, substitute here. So A, B, cos 0 is 1. So AB into 1 is how much? AB. So this is maximum. Dot product of two vectors is maximum only when two vectors are parallel, or when angle between two vectors is 0 degree, then a dot product is said to be maximum. So that is vector A dot vector B equal to simply A into B. Right? Then come to the fourth property. Dot product of two vectors is minimum when vectors are perpendicular. If two vectors are perpendicular to each other, theta equal to 90 degree, then a dot product is said to be minimum. Observe here. This is vector A and this is vector B. How they are now? Vector A and vector B both are mutually perpendicular to each other at right angles to each other. So angle between them is how much? 90 degree. Now again use the dot product equation. Vector A dot vector B equal to mod of vector A into mod of vector B into cos theta. Or we can write A, B, cos 90 degree, because theta equal to 90 degree and here two vectors are perpendicular to each other. So we can write A into B Cos 90 is 0. AB into 0 is how much? 0. 0 means this will be minimum. Is it clear? If two vectors are parallel, then a dot product is maximum. If two vectors are perpendicular, then a dot product is said to be minimum. So this is third and fourth property. Now we can move towards the next property, fifth one. Dot product of a vector with itself is equal to square of its magnitude. Here it is given dot product of a vector with itself. For example, vector A dot vector A, vector B dot vector B, or vector R dot vector R. Dot product of vector with itself. It is multiplying with itself value. And this is always equal to square of its magnitude. That is, vector A dot vector A is equal to A square. Observe here. Again, I am going to consider same equation. Vector A dot vector A equal to, we know the formula, mod of vector A cos theta. Both are having same value here. So mod of vector A means A into cos theta. What is the value of cos theta? Theta is equal to how much? We considered same vectors here. Same vector means this is vector A. Right? Again, I am going to consider the same vector again A. So both are same means the value of theta is 0 degree. So cos 0 is how much? 1. So the equation becomes A into 1. A into A is how much? A square. So when a vector is multiplied with itself, then it is always equal to square of its magnitude. Is it clear? Then here always remember, we will not get any negative sign. For example, I want vector A dot vector A. Here we wrote mod of vector A, mod of vector A. Here, whenever you are writing mod, its value is always positive. For example, if I am going to consider mod of -7 and mod of 7, what is its value? Mod of -7 is also 7. Mod of 7 is also 7. Here mod gives only magnitude, no directions. So always its value is positive. We will not get any negative value here. Yes, now we can study the next property, dot product of unit vectors. We already studied the types of vectors. In that, unit vector is one of the vector and its value is always equal to 1. So unit vectors are usually used to represent the directions along x, y and z axis. Or we can call it as orthogonal unit vectors. This is very important. Orthogonal unit vectors. Orthogonal unit vectors. What do you mean by orthogonal? Orthogonal means mutually perpendicular. All these unit vectors are mutually perpendicular to each other. So we can call it as orthogonal unit vectors. That means I am going to consider three-dimensional. This is x-axis. Let us take this is y-axis and this is z-axis. Three-dimensional x, y and z-axis. Unit vector I cap. This is used to represent x-coordinate. And for y-coordinate we are using j cap. For z-coordinate we are using the unit vector k cap. I cap, j cap and k cap. These are the unit vectors used to represent three-coordinate system. Is it clear? Now, I want to calculate the value of I dot j. What is the value of I dot j? Yes. Can you tell me the value of I dot j? This is dot product. See here again I am using the formula mod of vector I, mod of vector j into cos theta. Same formula we can use here. Mod of vector I is I, mod of vector j is j cos theta. Theta value is how much? Observe the diagram, three-coordinate system. Vector I, vector j, x-axis and y-axis, they are mutually perpendicular to each other. So angle between them is how much? 90 degree. So cos 90. Cos 90 is 0. 0 into anything will be 0. That gives I dot j. Vector I dot vector j is equal to 0. Is it clear? Then similarly, when you are going to find the value of vector I dot vector k, I cap dot k cap value. Again I and k. Remember I, j, k. All these three axes or the three vectors are mutually perpendicular to each other. Anyhow, angle between them is always 90 degree. Cos 90 is 0. You can take I dot j or j dot k or k dot I. So always they are perpendicular. So that value is equal to 0. Observe here again. I am going to write mod of I, mod of k, cos theta, theta is 90 degree, cos 90 is 0, 0 into anything will be 0. That means I dot k is equal to again 0. Then we can take j dot k, I dot j, we can take another one j dot k. Again I am going to write the same value, mod of j, mod of k, cos 90. So cos 90 is 0, 0 into anything will be 0. So j dot k is again 0. Is it clear? So in general we can write I dot j is equal to j dot k is equal to k dot I, and its value is always equal to 0. This is very important. When you are going to solve numerical problems, whenever it comes I dot j or j dot k or k dot I or k dot I or j dot I, anyhow its value is always equal to 0 because these are mutually perpendicular to each other. Is it clear? Similarly, now I am going to find the value of I dot I. Can you tell me what is the value of I dot I? Again use the same formula. Mod of vector I, cos theta. What is the angle between I dot I? I dot I means the same angle, both are parallel. So theta value is 0. So now mod of vector I value its magnitude, because it is a unit vector, its value is how much? 1 into cos 0 degree. So 0 degree is 1 into 1 into 1, and its value is how much? Again 1. So I dot I is equal to how much? 1. Similarly, can you find j dot j? J dot j is equal to, again the same formula we can use here. Mod of vector j into cos theta. Theta is 0 degree. Mod of vector j is what? Its magnitude is 1. 1 into cos of 0 degree. Cos 0 is 1. So the answer is again 1. So j dot j equal to 1. Similarly, k dot k is also equal to 1. So we can write I dot I is equal to j dot j is equal to k dot k is equal to 1. Is it clear? So when we considered the perpendicular vectors, its value is 0. When we considered parallel vectors, for dot product its value is equal to 1. So these are orthogonal unit vectors, or we can take dot product of unit vectors. Is it clear? Then now we can study the seventh property, dot product of two vectors in 3 dimensions. Yes, how to write dot product of two vectors in 3 dimensions. Yes, I am going to take vector A dot vector B is equal to, how to represent here? Ax I cap plus Ay j cap plus Az k cap. This is the representation of vector A in 3 dimensional. Dot, then vector B, it is going to represent again in 3 dimensional. So its magnitude means Bx. Bx means what here? The magnitude of vector B along x-axis. By, magnitude of vector B along y-axis, similarly for z-axis. And I cap, j cap and k cap, that represents its direction. So we can write Bx I cap plus By j cap plus Bz k cap. Right? Or we can write it as vector A dot vector B equal to, let us multiply Ax into Bx. Remaining is what? I dot I. What is the value of I dot I? Just we now studied I dot I equal to 1. So we got Ax into Bx. Then similarly, ay into by, j dot j value is 1, so leave it. Then similarly, az into bz. So its value will be k dot k equal to 1, so we got this equation. Similarly, we have to multiply. So each term here, remember this formula. I dot I, j dot j, k dot k. Whenever it comes, its value is equal to 1. If it is I dot j, j dot k dot I, it is always equal to 0. So whenever it comes I dot I, write 1. Whenever there is I dot j, then write 0. Finally, we will get this equation. Vector A dot vector B equal to AX BX plus AY BY plus AZ BZ. Then we can write here, we know the formula AB cos theta. We know that vector A dot vector B equal to what? Mod of vector A into mod of vector B into cos theta, or simply we can write A B cos theta. So in place of A dot B, we can write AB cos theta is equal to AX BX plus AY BY plus AZ BZ. We want cos theta here. So cos theta is equal to, we can write AX BX plus AY BY plus AZ BZ divided by AB. What is the value of AB? How to represent A? We already derived magnitude and direction when we studied resolution of a vector. So there we derived an expression for magnitude. A equal to root of AX square plus AY square, or in that derivation we considered R equal to root of Rx square plus Ry square. That derivation you can remember here. So this is three-dimensional. So in place of A, I am going to write square root of ax square plus ay square plus az square. Similarly, magnitude of B is what? Square root of bx square plus by square plus bz square, where a equal to square root of ax square plus ay square plus az square, and b value is square root of bx square plus by square plus bz square. So this formula you can use whenever they ask to find the angle, or we can write theta equal to cos inverse of this equation. So this is dot product of two vectors in 3 dimensions. Now we can study some examples of dot product. The first example is about work. Work is equal to dot product of force and displacement. See here. So W is work, which is given by the product of force and displacement. Force is a vector quantity. Displacement is also vector quantity. When we multiplied force and displacement, so whatever the answer we can get, so that answer is a scalar quantity. So we are going to call it as dot product or scalar product. So we have to write a dot here. W equal to F dot S, or we can write F S cos theta, because we know that mod of vector F mod of vector S into cos theta, or we can write Fs cos theta. This is one example for dot product. Similarly, second example is power. Power is equal to dot product of force into velocity. Force into velocity. Force is a vector quantity. Velocity is also vector quantity. When these two terms are multiplied, whatever the answer we can get, it is a scalar. So we are going to call it as a scalar product or dot product. So how to write the equation? P indicates power P equal to F dot V or Fv cos theta. Is it clear? So these are some example for scalar product or dot product. So this is all about scalar product and its properties. And in the next session, we can study the vector product, or which is also called as cross product.